Okay, let's begin. Hello, I'm Nyotko on the forums. If you don't know me, hi. If you know me, hello. I will try to show you how we print one of the parts on the CGI and how optimize the process so it takes less time and you don't lose quality, because originally this part was solid. This is green tech, very nice. Then I had the idea to try and flex on. This is a smart materials flexible, semi-flexible. I mean, Ninja Flex is more flexible. This is quite elastic, but you know, can take a punch. And then we found out that we actually needed some solid part. So this is a two parts fit where the flex stays below, solid goes up. But the interesting part that I don't have here is that we have made this solid green tech on a shape that allows it to be flexible, even though this green tech it's quite solid. So let's begin. For this part, as you can see, it has a springy shape that allows it to be printed in solid. We use green tech, we use a lot of green tech for the CGI. And also it allows to get quite a punch and still be flexible, even though it's solid. So, for example, let's begin. Okay. To print this, the first thing you will notice is that the area that works like a spring has a very tough overhang angle. You see on Simplify the G code view, you will see that we are taking jumps of easily 2 millimeters on the air. So for this, if you print it like, for example, this profile uses 0.2, which is fine for most of the things, but not for this. So immediately what you will do, it's probably change this to 0.1. 0.1. Sorry, my English is really bad. So if you change this to 0.1, now you get a much more interesting and clean overhangs, as you can see. Yeah. Now the lips, each layer, are more or less just a millimeter. So it's easier to print, basically, because you are printing less material on the air, because the layers are very thin, so you have more material to be supported over the previous material. I don't know if you get that, but basically it prints better at 0.1. The problem of doing this is, the first thing you will notice is that this will take what? Let's say 30 minutes, but okay. The problem is, this is 60 millimeters second basic standard fast quality. But to print this kind of overhangs, you actually need to at least print to 40, maybe 45. I could do 45 with my fans, but that's another story. So we're gonna set this to 45, 0.1, check the temperature to be something cold. And if you do this, you will see that you have a 43 minutes print, which is fine, but let's see. First thing we need to adjust to have a basic profile is 6 tops, 6 bottom, three perimeters to make the 0.1 solid enough. Let's see. Now we have a 47-minute sprint, and also is not quite solid yet. We have a lot of gaps here, and the spring should be as solid as possible, so it's flexible, but also it doesn't snap. So for example, we're going to use 7 outlines, and now we have the spring area very solid. But now the print time is 52 minutes. Okay, so first thing we will do is use the cross-section view and check where the complex part starts. That is something around 2.9, yeah, 2.8, 2.5, yeah, 2.8. 2.80 millimeters is the start of the complex part. So first thing, we will duplicate this profile. This already has our high quality settings for the spring area. And now we will define the bottom. The bottom of the print will have much less quality. So I need to go from the beginning to 2.80. We told to the slicer to stop at 80, and this will start at 2.80. Now the first profile will be now 0.2. We will print 10 degrees hotter and faster, really fast. So see, everything's okay here. And now you have two basic processes. The bottom that will print really fast, and the spring area that will print at a very nice quality. But the bottom now has a lot of bottom on top, so now that the layer is bigger, we change the top and the bottom and the bottom to 3. Okay, 33 minutes, and we don't need that much outlines. So the bottom will have 3 perimeters, a normal amount of top layers, and then we have the high quality part, spring area. Okay. Now we have two parts, the spring area, the bottom, but also we have another two parts here on the print. You have this area that doesn't need that much quality, so let's do another profile. No, but let's copy the low quality, that is the basic fast. Let's do a cross section again. Let's check when the spring finishes. You can see it's around 12:30. Let's copy this, and we're gonna start printing this new process at 2:30, and the process below will stop at 2:30. As you can see now in the G-code preview, now we have 3 areas we have lowered the time to 26 minutes. And we have the bottom that doesn't need much quality. This print area that now is 0.1 and prints slow, nicely. And now we have the area that holds the bearings, that also doesn't need that much quality. And in the end we have the screw area. This should have a bit of quality. It doesn't need that much as the spring area, but maybe a 0.50 should be okay. 0.50. So let's get the basic glow. We copy it, Control C, Control B, copy paste. Okay, now this new process, again we go to the cross section view. We check when the screw area starts. Here we go. I think 19 millimeters. Okay, so this last process will start at 9.19 and the previous one will stop at 1.9. Okay, and now let's check. Okay, now we have a 28 minutes print, which is not bad, but also we can do a little bit better because we don't need 0.1 for this. 0.50 should be okay, and also it doesn't need that much lines perimeters. Let's see. The way you can check if the resolution is okay or not is to try to see the angle that makes each layer, and for this is a bit too much. Maybe my fans can do it, it's not a problem, but in general 45 degrees is the standard. Well, I can usually print 70 degrees, maybe 80, sometimes more, but depends. But as you can see, 1.50, 1.5, 0.50 should be okay for this. If your fans ain't good enough, try to lower it to 5.30. And here you see the angle, the degrees between each layer are lower, so it will print better. And now let's check one thing. You see all these blue lines are because we have copy and copy and copy paste all these processes. So one of the things that all the process has by default is the first layer speed. This is usually low to improve the beta addition, but in this case we are already printing over the object, so we don't need that. So let's change the speed to 100. 100 and 100. And now we have very nice process with 3 different layer height, 0.2, 0.1 0.2 again, and 0.30. 0.13. This way we distribute the time of the print for each part, and we improve the print. We print faster, and we print faster, basically. This way you can do mass production without, you know. First we have around 50, 60 minutes tops. Now we have 26, so we can print more than one at the same time and get a very nice quality. Other important thing that I would like to add is that in general the first layer height, the 30%, should be the same on all the processes, because if we change this to 100, which should be what we should do because we are printing over something, but Simplify doesn't know that. So if we change everything to 100, you will see immediately that there's a problem. And some people don't notice this, but you see, we have a gap here. And if we check carefully, we will see that the first layer here that goes slower, so it's the spring process, is being printed over the previous layer with a very small difference. This is because when you start to use the millimeter cross section, the program tried to make an approximation of what millimeter you set and what you are actually printing. It's hard to explain, but I think you get the idea. Basically, the first layer, it's 1/30% of 0.2, which is, of course, 0.26. So the first layer of the first process will be printed at 0.26. The next layer will be at 0.46, 66, 86, etc., etc., etc. So when the next process tries to kick in, he doesn't know that the first process was done at 130. So it goes bananas, basically. So you need to basically keep. You don't need to use the same first layer width, because you don't need to increase the adhesion to the bed. The flow. This increases the flow for the first layer of this process. Remember, each process is a different print. For Simplify, he just mixed them. So you can set the first layer height to 1.30, give the 100 on all the processes. Let's go 130, 100, okay, and again 130. Now on the G-code view, you will see that you don't have these gaps. You might have layers that print almost on the same height 2 times, like this. We have this layer will be printed a bit too much over the previous layer. To fix this, the only way to do it is to manually be changing the millimeters one by one. It's a pain in the ass, basically, because Simplify thinks of each process as a different print. You need to guess, more or less, where when one process will finish, let's see, I just changed it 0.05 millimeters, and now we have a gap. To fix this, the only way is to, like I said, change and the two processes to where one finishes, where the next starts. And there's a point where you go bingo, and you feel very happy. 240. Here we go. Yeah, perfect. We have perfect first layer that will cover that height, and they won't overlap one with the other. Maybe a tiny bit, but you will not notice this. And let's check the top process. We have the same problem here in the top. This layer will be printed a bit over the previous one. So, like I said, change the end to something like this, and start with 0.10 more than the previous. Let's check. No, now we have a gap. There's no automatic way of doing this. You need to do it one by one, checking, reviewing the G-code preview before printing. That is a very important thing, always. And as you can see, well, we have a bit of overlap. If you want to, you can do it. And basically, we have 26 minutes, a very nice print for Green Tech PLA with the spring, 5 different times, and good quality. Yes, I hope so. I'm printing right now 3 of these. As you can see, I already have a process where I did all this. I will show you how the print looks when it finishes. And as you can see, we have 0.2, 0.1, then 0.2. Here you can see the difference because the first layer height and probably the temperature could be a bit better. And then we go again to 0.1, 0.13, something like that, and it works. And a very beautiful overhangs for this level of overhangs, of course. I hope you enjoyed the video. If you did, thumbs up. If not, I don't care.